All right, so when we're deciding if we want to use disk or shell method, sometimes one method is easier than the other, but they both work. And sometimes one method is actually impossible to do. And we'll see an example of that with number 5 here. So we want to find the volume of the solid formed by revolving the region bounded by the graphs of, our first one is y equals x cubed plus x plus 1. I've already used Desmos to graph that and sketched it here so we can see it. Y equals 1, which is going to be this line. X equals 1, which is here. So this is the region that we're talking about. I'm going to fill that in real nice so we can see it. And try and smooth that out. It was a little sloppy there. All right, and we are going to revolve that. I'm going to get rid of this thing now. We don't need that. Okay, we're going to revolve this about the line x equals 2. Okay, so this is our axis of rotation. This one's different. This is the first time we haven't revolved around the x or the y axis. So imagine doing that. That's going to make that region just kind of come over here like this. That'll be filled in. And then we've got this, so like 3D object there, okay? All right, so what we want to do is find the volume of this. So if we're thinking about doing the washer method, because it has a hole in it, we would slice perpendicular. And the thickness of those are in the y direction. So if you wanted to use your washer method, it would have to be in terms of y. So you would do pi and then everything dy. Now, in order to do that, that means this thing would have to be solved for x so that it's in terms of y. And there is no way to do that because we would need to plug that in somehow for the radius. Well, we would need inner radius and outer radius, which I didn't put in there. So we would have to do inner radius squared, outer radius squared. But anyway, for this outer radius, we would have to be able to solve that for x, which we just can't do. So disk method is impossible. So let's erase this stuff. Go away. One more. Okay. So if we've decided then that we have to use our shell method on this, let's set up those shells. The shells are going to be made so that they are parallel to that axis of rotation. So here is one of them, what one of them is going to look like. Notice this shell has a thickness in the x direction. So everything here is going to be in terms of x's, which is what we want. We can't do it the other way. So our volume is going to be in shell 2 pi, and we want the radius in terms of x, the height in terms of x, and then dx. So let's start getting the pieces that we need. All right, first in the x direction, we're going from 0 to 1. And now we need to think about the radius of this cylinder. Now, normally, all the other problems we've done before, we said, oh, the radius was just x. But x is this distance here, not this distance, okay? So what we need to do is this whole distance here is 2. And if this is x, that means the part that we actually need, it's not x, it's 2 minus x. And that's what we'll need to do when we rotate around something that is not the x or y axis, is we'll have to make that adjustment. Now, we want to find a function for the height. The height of the cylinder is determined by that function, x cubed plus x plus 1. But that gives us this entire height. We don't want that piece of it, okay? That's not part of it because our volume, our solid is kind of floating up there. So if this whole thing is the function and we don't want that little part, we just have to subtract 1, okay? Because that's 1 unit up. Dx. That was the hard part. It's set up. Now just comes the easy calculus stuff that we're used to. That's a great sentence, right? Easy stuff, easy calculus stuff. All right, so we have 2 minus x, and then x cubed plus x. because the 1's canceled. And before we can integrate that, we're going to have to FOIL it out. So we get 2x cubed plus 2x minus x to the 4th minus x squared. Hope that looks right. I know that's not in standard form. I hope you're okay with that. All right, so this is going to be x to the 4th. So it looks like 1/2 x to the 4th plus x squared minus 1/5 x to the 5th minus 1/3 x cubed. All right, I think that's right. I'm checking on my answer key just so I don't make lots of mistakes. Try not to make lots of them. We're going to evaluate from 1 to 0. So first we plug in 1. It's going to give us 1/2 plus 1 minus 1/5 minus 1/3 minus, then we have to plug in 0, which wonderfully is just going to give us 0. And then go ahead and put that in your calculator, whatever you need. We get 2 pi times, turns out to be 29/30. So our final answer is 29 pi over 15. So that is the shell method. So now you have 2 different methods you can use for finding volumes. And like I said, which one you use depends on what the problem is better suited for.